This is number 9 on the midterm review. It's a vector problem, so we're going to just jump right in. So we are told that a river flows 3 kilometers per hour south. Physics students can paddle their canoes 4 kilometers per hour east. What's the resultant speed of the canoe? So we want to figure out exactly how fast it's going to go. So visually what happens, we have our river, and it's flowing 3 kilometers per hour south. Then we have our students who can paddle east, which is to the right, 4 kilometers per hour, so they have a longer vector. Okay, and ultimately what's going to happen, if you can paddle to the right while something is consistently nudging you or pushing you down, your actual resultant path is going to look more like this. But, straight. So what's going to happen is your resultant vector is going to go from the corner over in that direction. That's what's going to happen to you. Now, this doesn't quite look like a triangle, but it'll still work. Basically what happens, you're going to make a rectangle, so the sides of your triangles are going to remain exactly the same. So no matter which way you draw it, your problem is actually going to be okay and work out. So we have a triangle here. It's a right triangle, and it is made up of a side of 3 and a side of 4. So to find the resultant vector, which is VR, we're going to say VR squared is equal to the velocity of the water squared plus the velocity of the students squared. Now to get VR, it's going to be the square root of velocity of the water, 3 squared, plus the velocity of the students, 4 squared. Now 3 squared is 9, 4 squared is 16, so that's going to be the square root of 9 plus 16, 25, which is going to give us 5 kilometers per hour. So if you recognized initially that it was a 3, 4, 5 triangle, you could absolutely solve it that way and just say 3, 4, 5 triangle. If you didn't, mathematically you still get the same answer. So our canoe is actually going to travel 5 kilometers per hour. In what direction though? So our resultant answer, 5 kilometers per hour. And we are moving to the right, which is east, and down, which is south. So it is going to travel 5 kilometers per hour southeast. Now you could find the angle that it's directed, but we don't have to in this problem, so we're just going to leave it at that. So it is traveling 5 kilometers per hour southeast.